So digital twins, I think a topic which is gaining a lot of momentum, traction, interest, and we hope that in the next 1 hour we'll be able to leave this room a little bit more informed and take away some meaningful conversations as well. Why is this important? Why are we talking digital twins? What is a digital twin? How can it push innovation forward? And how will it help the country? I think with about 10 lakh crore earmarked in the FY24 budget for the country, if you need to build that kind of infrastructure, it's fairly large, 37% increase. And the next 5, 10, 25 years of the so-called Amrit Kal period, that kind of infrastructure, if it needs to be built, we will need innovative methods. We will need solutions which will be able to address the problem of doing more with less resources. We will not have as much money or as much people maybe not, we will, but skilled workforce to be able to address those kind of challenges. With that said, BIM, Building Information Modeling, and digital twins, what are they? Essentially, we come from a world where from 2D CAD drawings, we've graduated to, designing in 3-dimensional, which is models, and now digital twins, which actually take a lot of feedback loop on data that's available to do simulations, to come up with projections, preempting problems and creating solutions from them for them upfront. If we have to discuss all of this with me, I'm going to be probing and asking some questions to my colleagues to get into details. We've got coverage from the hardware fraternity, the pure tech community. We've also got overseas experience. We've got teams which focus on computational mathematics also with us. With that as the background, let me open this up a little bit and go, panelist by panelist, and ask them what are some real use cases that they've actually, deployed when it comes to digital twins, whether it's in terms of operating assets or new build that they are looking at. And let me start with Vinod, maybe a quick little bit of an introduction and some examples of what CISCO is dealing with under his leadership in digital transformation. Vinod.
Thanks, Puneet. Good afternoon, everybody. Good to be here. My name is Vinod Karumampoyil. People who can pronounce that, I know you're awake in the afternoon, okay? I lead a program where we work with the government, the industry, and academia in accelerating country digitization. Right? The challenge which Puneet mentioned lies ahead of us. How do we do more with less and do it faster? We are on the same challenge, on the same page there, actually. CISCO is committed to making sure there's an inclusive future for all. And one of the areas that we can contribute is in the area of technology and digital twins. Most of you would have been aware, if you look at the Gartner's top trends of technology, right, is something that's going to jump from 10 billion to about 150 billion by the end of this decade worldwide. Answering Puneet's specific questions on what have we done worldwide, we've got some great use cases, what we've done for the logistics industry. I'm going to cross over the country borders and go to where Marco is from and talk about what we've done in the Rotterdam port. This was done pre-COVID era. The world has learned a lot from that. The digital twin that was developed there, we are trying to bring it in a season 2 version into the India and SAARC at a couple of the leading ports over here. Discussions are still on to make sure that we bring the right business use case and it's not just a technology stunt that goes on when we try to create it. CISCO by itself, I'm sure it caters to a lot of you in a direct and indirect fashion. I think CISCO has done a digital twin for its supply chain using GIS, Puneet, And this is what ensures that any customer who uses CISCO technology today and has a problem when he returns material which is defective gets sorted too, and we're able to simulate it across the whole wide canvas in which we cater to various industries across the world. So those are two examples that I want to just spell out, and I hand it back to you so that we can listen to others.
Thank you. The Rotterdam port example, and I think what will be important to know also as I move on to Marco to ask that question is the fact that what about, are there any learnings while we in India will have the maximum build that we do in the next 5-10 years? Are there certain success stories that we can learn from? Of course, customizing it and contextualizing it to our environment. And when we were having a conversation earlier, I asked Marco about, you guys in Europe will get structured data. Here we deal with a lot of challenges on the ground where not everyone in the ecosystem is, the last mile contractor may not even understand half the things that we're talking about. While that is changing, and it's changing at a very fast pace. But any learnings that we could get from you or examples that you have seen, Marco, from the Dutch side of the world?
Thank you very much, Mr. Moderator. So, goedemiddag. My name is Marco Marechal. So I was greeting you in Dutch at this moment. Great audience, great to have you here. And sure, I got a couple of examples. But first of all, I also like a little bit of interaction with the audience. So as a panelist, we talk about ourselves. You will hear it in the next 45 minutes. But I got one question for you. So if you bear with me, will the audience stand up so I get a feeling about what kind and type of audience we have? We are talking about digital twin. And most of the times I dream in visualizations of fixing the problem that clients or myself have. So the question is, which one of you is actually working on a digital twin or on a BIM? If you are working on it, you can stay put. And if you're not working on it, that's not a problem. Then you are my clients also. You can sit down. So please make your choice now. Thank you very much for your collaboration. That's 1, 2, 3. Dear panelists, we have a job to do. So anyway, thank you. Thank you very much. So the project I want to discuss about is a municipality. It's one municipality, but we work for a couple of municipalities in the world. And they got a big problem because there was a lot of congestion and they want to try to change it. And they asked me, Marco, can you do something about it? So I developed an image in my head that politicians and decision makers can have different kind of data and information based on different kind of measurements they want to have in the city based on real-time data and information to have, and that's the end goal, a more livable, sustainable city for the people to live in. So also carbon dioxide, climate change was all added into the equation. So we developed that in that area. So I thought I was developing a 3D model, but somebody else says, well, Marco, with clever algorithms and looking at real-time data information, also including the traffic management, you got a digital twin. So I got one daughter, and then I suddenly got a twin next to her. So that was a great moment in my life. So having put out different kind of algorithms, a digital twin, the end goal is making decisions based and playing on that for a livable, sustainable city. Because in the end, it is about people.
Excellent. I think making better informed decisions which are based on data and you're able to derive the right insights for the decision makers. And what I also took away from what Marco said was the people element, because at the end of the day, tech will not happen on its own. We may have ChatGPT and AI knocking on our doors, but I think we're still far from people not handling some of those things, and they will remain important human skills for us. Coming back onshore, I think let me pull in Udayan, who's the CEO of Oneirix Labs, and let me ask him what are certain use cases that they have looked at and their experience with digital twins. Udayan.
Oh, absolutely. Since most people sat down when Marco did his exercise, can I start with describing what a digital twin is? to
Absolutely.
begin with? Okay, so, suppose I were to capture Lucas's photograph here with my phone. I have his photograph. Would you call that photograph a twin? Would you call that a twin? You wouldn't call a photograph a twin, right? So now, if I can start with that photograph and convert it into something that behaves like him, not just looks like him, the photograph looks like him, but that's not enough. Something that behaves like him, right? Then that would be a digital twin. So starting from some aspect, some information of a real world system, if I can convert it into something that I can make it behave like that real world system, then that's a digital twin. So I am a computational mathematician. I have been running a computational mathematics company for 18 years, and computational models or mathematical models are models which behave like real world objects. What I am excited by, where it comes to digital twins, what I am excited by is now there's a lot of data coming in, and we can build twins not just out of assumptions, which we used to do for like the past 25 years, not just assumptions, but lots of real-time data. So now, to answer your question, I'll give just one example. Here's a project that we're doing right now. We capture real-time data on the traffic, on the streets, like vehicular traffic. And from this data, we build a model that will behave exactly like the traffic is behaving right now. Okay? And this is not just some general statistical behavior. It's going to predict into the future what your traffic will do, where the traffic is the traffic right now, right? Now, what do we use this for? We can actually run this digital twin model millions of times per second. Understand that carefully. That model can be run millions of times every second. And what that means is that we can simulate into the future what will happen if I were to take certain decisions. What decisions? We are actually taking decisions of which traffic signal to make green, which side to make green, which direction to make red, and so forth in an entire network of traffic signals. We have developed this technology and are using it. We have deployed it in proof of concept deployments in places, and we got 50% reduction in wait times in peak traffic in Indian cities. Okay, 50% reduction in congestion. Can you imagine that? Just using this idea of, mathematical models of real world, real time behavior. So that's a very successful example for me. There's many more, but I'll...
Thank you, Udayan. I could see Lukas twitching when he said, I'm creating a digital twin for you right here. But I think to that example that Udayan touched upon, when we were having our conversation, I said, I don't agree with you. All this is humbug. I don't believe you. And why did I say that? I said that, and with a reason, with an objective. When Marco asked all of you, how many of you know that? Our goal is that before we end, Marco to ask that question again and see have we moved the needle with this audience or not. So I will expect you to do that again. But coming back, what Udayan touched upon or explained was a real life example of a system, of a traffic, of a mobility problem, and all of us face that. But when we are talking about new build, infrastructure, roads, power plants, highways to be built, and then to be operated, it is multiple stakeholders. It's the sticky side of life where you got to deal with, a whole ecosystem, right from the time you design something to procurement, to award, to contractors, last mile execution. That's where the real challenge will be. And I think Udayan was keen to say that I'd love to take this challenge up. And I think if we can solve that problem, it'll be great. That brings me to Lukas. And what's the connect there with Lukas? Because a lot of this so-called computational mathematics algorithms, which we think is somewhere in the cloud, I think it's got to have a physical manifestation. That's where your IoTs, your devices, your routers, your networks come into play. So let me ask Lukas if you could share a couple of examples, quick introduction, and what you would like to cover. Lukas.
Sure, by all means. Before starting, I would like to thank you, Marco, for making sure nobody is sleeping in the audience. So let me briefly introduce myself. I represent Teltonika IoT Group. We are a company from Lithuania which manufactures IoT solutions. Teltonika Networks is a part of the group, and we focus on industrial networking equipment. Additionally, we have our operations here in India, which is run by a team of 80 people. So getting back to the question and the topic, I think we have a very good example of digital twin technology and how we can solve real life problems, and we have it here in India. So there is a solution of digital twin called predictive maintenance, which allows to use historical data and algorithms to predict if a system or a component of the system can fail in the close future, and so allows to act proactively and saves a lot of downtime. And one of our partners in India is called Infinite Uptime, which is offering predictive maintenance as a solution for various different industries. Let's take example of one industry of cement. So the partner in the cement industry has digitized more than 70 different plants with more than 3,000 different locations connected. And we have the data that it saved approximately up of 4,000 hours of downtime, which allows to save the costs and run the system much more smoothly. Thank you.
So 4,000 hours of downtime avoided. I think convert that to dollars or rupees and the ROI is in front of you. And I think with 50 new airports to be built, new industrial corridors to happen, 35,000 plus kilometers of national highways to be built, the amount of construction that the country is going to see, and if we can shave off some of these things, and while the example there was also from an operating plant, but it's an important input that goes into the entire digital twinning journey that we have begun on. My next round of discussion or question, I will start from Lukas again, and probably ask him, what is it that you see as certain challenges? How can we speed this up if we have to? What are some of, is it around people? Is it around process? Is it around technology? Are these challenges internal or are they external? From your experience, Lukas.
Thank you. Okay, so I would like to focus on one of the challenges. The challenge is about data privacy and security. Companies who are running digital twin technology are dealing with tremendous amount of data, and they have multiple challenges on making sure that their intellectual property is secure, that their clients' data is secure, and also that they comply with different regulations as well. We as Teltonika Networks focus heavily on making sure that our solutions come secure and reliable. And we have some good examples in India's market where companies like Adani Gas or prestigious organizations like GRGO has agreed to use our devices after running a lot of external and internal tests and making sure that their data is secure. Thank you.
Data security is one of the points that you've touched upon. But just elaborating that further, if I could go to you, Udayan, what do you think? I mean, having seen this in your mobility example or at other places, what could be some of those obstacles or bottlenecks? Given we all believe that this is an important area and we need to gain more speed in this, what could some of those steps be?
See, I think there is a technology challenge that I would like to talk about, and there's a related people challenge as well. Basically, the question I would like to ask about is the data enough? Can I use the data that has been provided to me to build the behavioral twin that I want to build from that data? Now, as computational mathematicians, mathematical modelers, we are asked often that, here, take this data, build this kind of a behavioral replica from it. Now the question is that enough? Well, many a times there are gaps in the data and there are various kinds of issues and there are lots of algorithmic techniques like, data fusion, Bayesian analysis, which we can use to cover up the problems with missing data. But there's a more fundamental question that, does the signal even exist in the data? Is what you want to extract from the data even present in the data in the first place? And that's what brings me to the people problem, because really sometimes no one is looking at how do we ensure that the correct kinds of data are being recorded in the first place. Lots of data is being recorded and sometimes the signal that you want is missing. So from the people perspective, I would like to see a world where mathematical modelers like myself are involved at the stage of data collection, not brought in at the last moment and told that here's the data. Can you do this from it? Many times I say no. Then they ask, well, then what can you do from it? So, the more you involve, the more the idea of mathematical modeling becomes a broader idea, and the more people get involved at the earlier stages, I think we are going to see more and more successes.
What I hear Udayan saying is that don't put technology for the sake of putting technology. Don't do innovation for the sake of doing innovation. I think it's got to be led by the desire to solve a business problem. What is it that you are solving for is very, very important. And I would encourage even later on in the session for this group to ask us questions and pose them to any one of us on the panel. And to contextualize it further, if I am building highways in the country, and this is a classic point that comes up. There is an existing route alignment between two cities. Now I'm adding another highway. I have a certain projection that I'm going to collect toll of a certain value on a particular highway. As a system, I am building more roads around that. There will be an interplay between this. So a systemic approach. Or similarly, when I look at, constructing buildings or industrial plants, I think there are so many interdependent plays over there that you need to solve and start by asking the right questions. Once you do that, I think the horse will be ahead of the cart, which typically becomes a problem. Because otherwise you could be just generating more data, more information. It's only garbage in, garbage out, and you're turning the handle faster. I think that's what I draw from that. Let me bring Marco in and get his perspective as well on this.
Thank you very much, Puneet. I'm sorry to say that you're all wrong. Sorry. Because at the end of the day, and I will give you a blueprint for the next 60 minutes, and maybe after me, Mr. CISCO has a better answer. That will be challenging for him. But it all begins seriously with a statement. So I saw your minister, he opened at 12:30 yesterday, and he made a clear statement. India is at position number 5, looking at innovation and technology and doing your best. And in the next couple of years, we will be on the first place. That is a statement. You need a government statement, not only money, that's the investor part, but you need it as a statement as a country. Because when you do that, all different kind of university, knowledge institutes, but also big companies like CISCO, and also other cities, territories, and other governments will follow that statement. And of course, you also need money to get digital twin to the next phase. But you really have to have a solution to the problem that you are going to be fixed. And try it with use cases, try it small, not too big, and just start from there in that area. So you need, like I call it, the golden circle and the golden triangle. So government, companies, also different kind of companies who want to invest, like my panelists, and also in the equation, the different kind of knowledge institutes. And finally, as I said, the people, because you will have to adapt it, you will have to use it, and you will have to take it to the next step, because scale up will be a big problem, because we got too much use cases also in the Netherlands at this moment. So scaling up will be a good idea, but it will take time.
So I didn't get the part where all of us were wrong, but I still. But that's okay. I think we take that for now. What I want to go and ask you, Vinod, is, are we? I mean, while yes, we need to. The government has a vision. We are headed in a particular direction. We are at a certain number. We want to go to a certain number. Are the enablers in place? Is there any feedback loop required into hard contracts, into policy, into implementation? Because still it doesn't manifest into a contractual understanding. It remains as good talk. And I am a firm believer that, while a lot of innovative methods are emerging, I'm also a part of something else where we drive lean construction, lean philosophies, which is about, it comes from the Toyota School of Management and Production. But leaving that aside, that's a similar conversation we have there, that till it doesn't get the leadership blessing and it doesn't get incorporated into policy and into contracts, some of these things will not percolate enough, because it has to affect an entire ecosystem. You need to get skilling done accordingly. You need to have, right crop coming in from the educational institutes that understands that. You need to have right, framework for litigation around it also. So what in your, experience, Vinod, are some of the things that you would like to touch upon when it comes to debottlenecking and speeding up the adoption of digital twins?
Puneet, I'm from Mumbai, and in Mumbai we do two things. We sit in traffic most of the time, and then we see a lot of movies, right? So there are two things that we do. I'm going to pick up a movie example to bring to the point that you're alluding to. I tried to find a Judua movie with Salman Khan, but I couldn't come up with a simile. So I'm going to go to the Marvel Cinematic Universe and to the Iron Man movie of 2008, right? There are two things he does in that movie, which is going to Udayan's point, right? You can do simulation on something which is change the arc reactor without doing a digital twin, and then he builds a suit using a digital twin, right? I'm going to transpose that. We'll argue about what was smart, what was not smart, what made good watching, and we were all waiting with bated breath where Potts pulls that arc reactor out and puts another one back. Extremely good movie watching, a lot of popcorn eaten, and we were all happy with that. But if I were to draw the parallel to that, Puneet, the point is you actually need, based on the business outcome that you want to get to, classify what are the strategies to be deployed across a whole lot of activities that we're doing, right? It would change, for example, when you build, let's say, the 200 odd airports that we want to have, the 50 big ones and the rest of them after that, right? It would change based on what the Udayan scheme sees people are flying, right? It would change based on, let's say, what agriculture do we want our farmers to grow, or what crops do we want to grow other than cereals and move across to millets, for example. It would depend upon what we want to do with healthcare as we develop the next cycle of vaccines which are done in the country, right? So depending upon each one that exists over there, it requires a clearly thought out plan. And this is something that we try to develop along with the ecosystem and build the thought leadership so that there is vision, like Marco just mentioned. There's a vision which needs to be followed with a mission, number one, and more importantly, a clearly graded action plan to do it. We do not know all of this, let's be clear, right? I think people who are watching the previous panel, right? Do we all know where the AI ML is going to land up? With the power that we have, with the compute power at the moment, with all the smart algorithms which Udayan and his team would write, number one, and the speed at which they would write it, and soon somebody would write it for them, and they would just try to decipher what it is, right? We need a leap of faith, in my opinion, on a few things which are not risky for the country, right? And on the others, we need a very systematic approach, number one, and a feedback loop which is very quick, because we do not have the time nor the patience at this point of time to get to the position that we want to get to. So the framework, if I can put it, number one, backed by the visionary angle, plus a graded approach is what would get us over there. That's my thought.
Excellent. So what I hear you say, Vinod, is a calculative leap of faith. It is not a blind leap of faith. And I think we have the ingredients, we have the platform, and the clear ask is in front of us. Because, I mean, if I were to precipitate this further, and this is the third such smart city or convergence program I'm at, we've moved now from that post-pandemic situation, hopefully, fingers crossed. There was some stress there. Then we went into, certain geopolitical issues with the, inflationary trends around us. Supply chain was a problem, and I'll come to why I'm talking about this, where we're also talking about some recessionary headwinds in front of us. And I'm always a believer that tech has to make sense for business. And if we don't, if we leave it to a leap of faith, and if we don't put the framework in place, then we will continue, and we will only still have 3 people standing up in this room later also. We need more believers, but we need to also have a method, and we need to have a playbook of sorts, which allows people to understand and differentiate. This is what good looks like. This is what digital twin looks like. These are the steps I need to take, and then let them evolve and take it further. I think we still have good time, and I would encourage, and maybe more pressing, I would not say more pressing, but some more issues which are in front of us. How can digital twin, for example, help us address the climate change? The entire embodied carbon tracking or decarbonization journey that we are on. And I'd like to keep that as an open question for any one of the panelists to come in and respond on. And if there are other points that you would also like to touch upon. Anyone, it's an open question.
Puneet, we're going to have about, 700 million people living in cities now. I think you corrected the number, right?
820. So,
800. Can you just tell the math for the audience so that they get it?
So by 2047, 50% of our population is going to be living in cities. And if I extrapolate that number, that's 820 million people. And we were having a laugh where countries are 20 million as big as our cities over here.
We only have 20 million people in the Netherlands, so thank you for that. That's
but-
one city.
Yeah, so I think that's your number right there, Vinod.
So if that is the number that's living in cities and all of them are living in buildings, and you can assume, right, buildings are going to be vertical. Even today, in the developed countries, if I were to use it, where it is not so populated, about 46% of the carbon is because of urban living in buildings, right? This just goes to show the amount of effort, planning and design that we need to put in place to ensure that we are anywhere getting close to the net zero that we're talking about, right? If I were to just try to imagine what we need to do to get it done and why I believe we can do it. The reason I believe I can do it is that our cycle for correction of anything that we attempt to do, even if it is wrong, is going to get faster and quicker with the amount of computation, storage, algorithmic power that we have jointly with us, right? I'm sure I can see Udayan shaking his head over there, right? We actually believe there's going to be no problem in sensorizing the world. That is going to happen. The sensor, once collected, is going to lead to data. A lot of the data is going to have a lot of noise. Right? We have to weed out the noise out of this to pick out data which really matters. Once we've done it, if you're able to frame the right, let me not even use the word algorithm, right? The equation that is required to solve or to model everything, which is something that we will see would happen at a great pace, number one. And I can tell you right now, the young engineers in India will do this for the world, not only for us, but for across the world, right? We're going to build this up, number one. All objects would become models and get created within no time. I can tell you that right away. How do these interplay and work is the tricky element, right? Now, that is the element where it requires a domain to step in, and that is how we're going to shape it up. If we do that for buildings as a whole, let's start with a simple one, right? This hall, how long will it take for Pragati Maidan to go net zero, for example, right? Can we use it? Can we do that with the net zero concept? You don't need to do that, right? You can actually put a whole lot of solar on top, number one, ensure that the air conditioning is right. It's a little colder on this side. It was not so over there. Let's put some IoT sensors and balance it out, right? You can do a lot with engineering, but I think you can do a lot smarter if you do it with a digital twin, right? I go back to my example, right? When the person is pulling out the heart, you might as well test it out in the digital twin before you mess around with an arc reactor, which has got some, nuclear stuff lying within it, right? I believe it is a time for us to do this as we go on building into Amritka.
So clearly the technological prowess is there, the timing is right, and I think we also owe it to our next generations. I think that's also something, given this kind of, it's a good problem to solve, and we are in that pole position as a country, as a group of professionals, to address this problem upfront, because we can take a leadership position in defining certain solutions which can then be replicated across, because there will be 1,000 such halls, such Pragati Maidans. There will be our own offices, and all of that, they become big potential opportunities for us to play this out. The technology is there, the demand is there, and we owe it to them. Marco?
Yeah, so when I said you were all wrong, and me included, I meant that data and information and the digital twin is also about people. So it's a little broader than only data and information. So that's why I said we're all wrong, me included. So what we did in the equation is for the digital twin, for as a municipality and as a country, and maybe that can help you also, because most countries signed off the agreement of the climate change of Paris. And I think India did also, but I'm just checking it. So those statements, they are made in this climate change agreement of Paris. It has been translated to each country. And those are cold hard figures. And you can put it in the equation to have a start, to have a measurement, which is real-time data and information also, to take it to the next step for India as a country to look at the climate change and what is going to be for the next year, 2030, 2040, what has to be done nationwide also. So that was my statement in the
Excellent. Udayan, would you want to come in if you have a perspective? Or if not, I'm very happy opening this up and checking how many people have now understood digital twin, and for Marco to run another simulation on the audience over here. Udayan, after you.
Yeah, just quickly. I mean, just think of this, digital twin-based traffic signals. If we could reduce the wait time by 50%, if this could be deployed in every city, you are saving, you're reducing energy by 15%, you're reducing pollution by 50%, you're reducing crankiness by 15%, and you're allowing Vinod to see 15% more movies. So, I mean, it's amazing, isn't it, if this were possible? The challenges that I see is that, from the point of view of procurement, whether it is large businesses procuring or whether it is governments procuring, our systems still are geared towards procuring based on cost. But cost is not the only factor here, is it? I mean, when it goes to procuring things based on mathematical models, it's not just cost. You have to be able to trade off cost versus quality, but it's not just two axes actually, it's cost versus quality versus risk. And risk is the third axis, what Vinod was calling, needing to take a leap of faith. Now, because models can be of various qualities and models can have various amounts of risk associated with them. As humanity, I don't think we have really figured out how to procure technologies based on the correct trade-off between cost and quality and risk. And that's a challenge that I think as a smaller company, I feel it. I'm sure as a very large company, even KPMG feels it, and everyone feels this. How do we deal with this? So I don't have an answer, but it's a challenge. I'm sure it's a challenge for everyone.
And I always believe that if you're asking the right questions, the answers will come. The problem happens when we think that we know all the answers, that the challenges. But yes, I think there are clear examples of public procurement moving from pure play cost-based procurement to value procurement also. It's few and far between. I think we need more voices, and I think that appreciation and understanding is clearly, I see that change happening, and we see examples of that across in our daily lives. With that, let me open it up to the audience. And okay, good. I see maybe the organizers can help us with some mics which can be floated around. There's a question right here, and then we will go back over there. Then this gentleman, sir, over here, and the one at the back. 4 questions we've identified, sir.
Puneet, you
Please.
started by saying that there should be a playbook or a template that could really enable widening of this and thereby having a larger audience of technical and connected people still not being aware of digital twin in the marketplace. So my question to both Vinod and Udayan, if you could just share the low-hanging fruit, modeling that you've been doing, which is in a commercial reality, which we should see this year. And similarly, Vinod, if you could give some illustrations of what CISCO's done here globally, which would enable a wider engagement with industry for this.
So I already told you about the traffic case. It was implemented as a proof of concept in one very congested Indian city. It's currently being implemented as a final product in 2 Indian cities. We hope to take that global. So not even low-hanging fruit. It's working right now. On other technologies I could talk about, there's a lot of work that we are doing in healthcare. Now might seem like a very different domain, but we are mathematical modelers. Our thought is very horizontal, like mathematics, right? Wherever we can use it. So where it's the same kind of idea. How do you collect data on patients, and can you really build a predictive model in real time of that particular patient? And that requires understanding of how humanity progresses through life, as well as understanding from data of a particular person how that particular person is going to progress. And then we can use that to try to design interventions in real time and to be able to solve problems that we cannot do without having such a close feedback loop. So there's a lot of work happening in my company and elsewhere, I'm sure, on healthcare, which is again based on this idea of digital twinning using data, in this case of human beings itself.
So maybe Vinod, and maybe I'll supplement with, there's a very relevant question you asked. Vinod, after you, please.
Let me give you an example of where we are close to a complete digital twin. This again, based on what we learned out of the massive project which is done in the Rotterdam port. We are hoping to have a season 3 actually of that, where we've cut and, let's say, carved out business use cases which would enable ships to come in and berth more effectively and offload the cargo that they have, make sure that the trucks which line up outside to move them do not stand for a long period of time, and get it enabled and moved out. Frankly, it's more of a simulation study, not yet reached a fully fledged digital twin. I'm hoping by the time we hit this Diwali, we will come out to the press and announce it if we pull it off, number one. That's one example. The other one is we've been working very closely with the NIUA, the National Institute of Urban Affairs, trying to see what we can do to enable the data that they have and convert that into models which could be used for smart urban mobility. Again, all the intelligent work is done by the smart engineers over there, which is helping the ecosystem get sensorization, get data, give them enough compute resources. Hopefully, if we pull that out, that will be one of the contributions we can carry as a part of India's stewardship under G20 and carry it further. Again, both are underworks. They are not fully functional digital twins. I need to call that out specifically so that I don't give you wrong information. I hope that helps.
So let me just supplement and I'll go to the question. I think this is a very valid question. How many of you used Band-Aid when you get hurt? When you get a cut, you use a Band-Aid? How does a Band-Aid work? You have a bruise, you have a cut. When you put the Band-Aid, the actual solution or the problem that you're solving, it's actually that little medicine that's on that part. But there is an application of that. I think what we are looking for is, when I say a playbook, is a solution architecture, and it will have to be nuanced to each sector and industry, but there is a common layering at the top that is required. We do this for a living, and whether it's highways or industrial buildings or hospitals or ports, I think the ability to bring the point solutions to address the business problem is very, very important. And there are templates available, but this is also evolving. We live in a world where the acceleration, the rate of change is such that things get, the shelf life is very, very small. So I think all of these can be, and we can get into more detailed discussion maybe subsequently, but yes, very relevant question and solutions are available. I'll just move on, sir, for the want of time. There was a question at the back. The gentleman had raised his hand. Sorry.
I would like to thank Mr. Udayan. I didn't realize I was...
Sorry, we can't. Where are you speaking, sir?
Right here, all the way.
If you don't mind standing up, thank you so much.
Mr. Udayan, I didn't realize I was leading a digital twin project till you clarified things. So we are right now building 1D computational models based on the last 10 plus years of data we collected. But our challenge has been with the tools that are available today for us. They are expensive and sometimes they are challenging as well. Do you guys think in the panel the tools will become more democratized, more accessible to larger audience in the future? What's your take on that?
Is it about the accuracy of computational tools, or are you talking about whether the computational tools are accessible to more people?
Yeah, the access for the computational tools, the tools that are required to build the models. We are right now doing one-dimensional computational models.
Computational modeling of what aspect?
The data that we have collected on our machines over the last 10 plus years. And we are trying to do what Lukas has done on his objective. We are trying to do prognosis on the component life? Should we be ready or something like that?
So let's talk about predictive maintenance, right? The
Exactly.
case study that he was talking about and that you seem to allude to. Um, so a lot of the work that is happening in predictive maintenance right now is not really based on digital twins. Sorry to burst people's bubble if I'm doing that. But really, I mean, the idea is everything that I've been saying that, and all of us have been saying that collect the data, build a computational model, and then the computational model is going to be able to predict when a particular thing will fail. Now, here is where comes the problem of, do you have the correct data? You have, in this case, you have a lot of operational data, but do you have the data of failures? And it turns out you don't have the data of failures. Why? Because engineers are not going to let their systems fail in the real world, are they? They are going to be, they are going to be really safe and not let anything fail. And so many a times we get asked this question ourselves, and there's a lot of operational data. There is no failure data, or very, very small amount of failure data. And if there is no failure data, what do we build this model out of? So this problem that you are facing right now, that your models are not helping you predict failures, is probably not just a lack of their existing models, but there being a lack of any model that could do it because of there being no data as such. And so what ends up happening in most, I don't know if that's true in your case, but what ends up happening in most predictive maintenance cases in the real world is that we are actually using IoT, a lot of sensors, to do a lot more sensing that would have been possible earlier when human beings were inspecting and observing and trying to ensure that things don't fail. So in that sense, we are doing much better because of the sensing. The algorithms, so-called, are still the same rules of thumb that we were utilizing 40 years ago and saying that when the crack density is more than such and such, then you will not fly this plane, and those kinds of algorithms are still the algorithms, because we cannot go to the next level of algorithms because of lack of data right now. I don't know how to solve that.
No. I think that's a valid point of view, and we are all learning. So this is also, I mean, we did not have the ability to do all of this 5, 10, 15 years back, or the back-end frameworks and the technologies which are there. Let me keep moving on, and we're left with a minute or two more. One more question, please.
See, I'm from fashion industry, and my question is, we've been hearing of digital twinning and virtual twinning, but in the fashion industry, which has much more larger carbon imprint, but the tools are so expensive, and the implementations, anything being worked on so that also we in the technology of fashion can utilize, or something we also can get the digital imprint or virtual imprint. Anything been working on that? I just want to know.
I think that may be an out of syllabus question for us, but I'm okay to, I don't know, fashion industry. I think you're alluding to the ability to have simulated,
clothing manufacturing, the clothes, the virtual. So
yeah.
anything being worked on that?
Anyone
Because it has
else
a huge,
would want
larger carbon imprint, but it has the budget which is very low in comparative. Because
okay, maybe we could, Udayan, if you want to take a quick response, and then we could wrap after that.
Well, the fashion industry started using the word models before us mathematicians started using the word models. So there is that similarity. But actually, it's the same word model, believe it or not, but let's not go too much into philosophy. It's, essentially, instead of building a mathematical model, they're trying to build a model of what a cloth or, what fashion will look like on you, the customer, right? And they are modeling that in front of you. And there have been attempts to do that using computation instead of using real world models. So essentially using mathematical models, and there is some progress there of trying to capture your data and trying to make, virtually tailored clothes fit you, so that we model better than the models who walk in front of you, model even more accurately what that particular tailored suit will look like for you. I don't think they have succeeded in this yet. There have been many attempts. I don't think there have been any successes yet, but maybe 5 years, let us say, into the future, there might actually be successful digital twin models for the fashion industry.
Okay, with that, I think we don't have time for another question, but I think the panel, the speakers, all of us would be available in case you want to, or you can write in to us later also. Marco, do you want to run another simulation on the audience, or let it be for now?
Sure, I will. If you please stand up for the last question. Thank you very much. You're a very good audience. So I hope you enjoyed this one. So when you look at the nearby future in 2030, do you think, will digital twin determine your life and your way of thinking, walking, and going around? So if you think, yes, I think that digitalization and digital twin will more determine my life, you can stay put. And if you say, no, Marco, not yet, you can sit down. You can make your decision now. Thank you very much. So what you are saying to me, that you allow yourself to be led by a digital twin. Well, CISCO, I hope your platform will be great. Thank you very much, audience.
Thank you so much. There's your leap of faith, Marco, that everyone's taken. Thank you so much. Back to the organizers.
Yes. Thank you so much, and I thank the speakers for the presentation. Now, before we close this session and move on, I would request our moderator to give away mementos to the speakers on the desk. Mr. Puneet and Narang, could you please do the needful? Mr. Vinod first. He's from CISCO. Mr. Udayan, Kanade, he's CEO Oneirix Labs. Mr. Lukas.
Lukas Milcius.
Okay, sorry. It's Lukas, you said. It's written Lukas. Dr. Marco. Interesting ending to an interesting topic. And last but not the least, Mr. Narang, could you be on the desk? We have a small memento for you too. Ruchika, may I request you to do the needful? Thank you so much for conducting the session. And this is from Exhibitions India, the organizers.